Hi everyone. I'm going to talk about chromatography in this video. So this is, I believe, the last video I'll make. So you in organic chemistry 1 lab, we're focusing once again on the first portion, which is separations and purification techniques. And you used you learned about thin layer chromatography, TLC, and experiment 4. And experiment 5, you guys did column chromatography. This is a form of liquid chromatography that you did. In addition, there is also GC, which you did in experiment 7 and experiment 11, and that's gas chromatography, but I'm not going to talk about that in this video. Gas chromatography also helps you monitor how much how your reaction progressed and how much reactant you might have left, and what your distribution of products are. That's also important to know for your final. Okay, so you guys did TLC and column chromatography of spinach, but there was also a portion where you used the 3 extracted samples in the extraction experiment in experiment 4. And you might have noticed, so I'll talk about that first. So you probably, first off, this is like TLC. So you would draw like a line at the top and a line at the bottom, around like 1 centimeter from the bottom and all that. So you would like ruler and just measure it and all that. But so your solvent you would first spot your samples. So let's say we had like 4 samples. So you had your original sample, which was the 1,1 to 3-nitrobenzoic to 2-naphthol to 1,4-dimethoxybenzene sample. Doesn't really matter which one it was, but we use this one just because the more absorptivity of 1,4-dimethoxybenzene is low, so that it shows up well. And then you had your organic extracted sample, which is your 1,4-dimethoxy. If you did it well, then would have a lot, mostly 1,4-dimethoxybenzene. And then your other row is 2-naphthol. And this one was 3-nitrobenzoic acid. And then essentially, the goal of TLC is just when you use your solvent, which was remember the solvent was different from your spinach lab. So you guys use 3,1-hexane to ethyl acetate. And this is also important. You should know how the solvent will be a mixture of something polar and non-polar, and you see the hexane is non-polar and ethyl acetate is polar, so you can see it's 3-to-1, so you have more non-polar than polar. So your solvent is more non-polar of character. So you could say non-polar, and this is your mobile phase. It's not 100% non-polar because then you wouldn't see anything, but you can see it's mostly non-polar. And then your stationary phase on the TLC, it's on the sheet. So it's not the shiny side, it's the other side where it has like the powder that cracks. So that powder that cracks is your silica gel. And it's your adsorbent, which is your stationary phase. And if you know what about silica gel, it's poor. That's all we need to know. And so you have a polar stationary phase and you have a non-polar mobile phase. So having this polarity gradient between the 2 phases, once again, like I was talking about phases in the last video about extraction, instead of having layers here, you have like the solid TLC. the silica gel on the TLC, and you have the mobile liquid, like mobile phase moving, and so that's operates your separation, the polarity gradient, as you can see, and the different components that you have, of course, have different polarities, and so they will elute, and like the relative order will be usually the same, and so you will get a separation. You either get no separation or you get a separation, but you do want a polarity gradient that allows you to separate your compounds. So you can change your mobile phase composition. You usually don't change the stationary phase. You can't really do that. And then, yeah, you should get a separation of some sort. Okay, so I'm gonna come back to the results of these later, but originally we hypothesized that your original sample has all three components. So you will see a distribution of 1, 2, 3. You'll see 3 spots here, and then the one for dimethoxybenzene, you will only see 1 spot for dimethoxybenzene. 2-naphthol, you should see 1 spot, and 3-nitrobenzoyl, you should see 1 spot if you did a successful extraction. So you're separating these components into each individual pure component. You don't want residue. If you see like 3 spots, 2 spots here, that means that your extraction wasn't 100% complete and you have impurities in your different samples. So you can assess how good of a separation you got in the extraction lab from doing the quantitative TLC analysis with your RF values. And you would, if you're taking Orgo 2 in the fall or in the future, you will also use TLC to monitor reactions. So like how you did in the end of the lab, like you will have a reaction, and then as you assume, it's not going to be 100%, like you're not going to get 100% yield, or you might have residue, and by using TLC you can assess the purity of your product and see if you had any impurities or like anything else like that. So it's a very helpful technique, and you should know about TLC for organic chemistry too. Column chromatography, not so much. Okay. So I'm going to come back to the extraction results. Okay, so I'm going to talk about the principle of chromatography now. So once again, it is, if you're looking at page 31 in your manual, it is a separation and purification technique. It is based on partitioning the sample between 2 phases, as I said. You do have, there's 2 different types. You have column and planar. So if you're going to categorize them, your planar type of chromatography is TLC because you have the solid paper coating, like on the you have the silica coating on your like plastic, and you might also note that like this is more like paper chromatography if you ever done it with like coffee filter or something, and then you have different colors, maybe put ink, and then you see it separate in different like components and different like colors of ink. So that's what TLC is. And then column chromatography is a column type of chromatography, and you have a tube, you have a stationary phase, so you put the silica gel on the tube, and you use pressure or you use gravity. So we use gravity. We never really use pressure because pressure will kind of force everything to move like the same in a sense, and speed everything up, so you might not get as good of a separation. Yeah, it tells you different other types of chromatographies if you're interested in this. You do these in like upper level chemistry classes. So liquid chromatography, gas chromatography, capillary electrophoresis. Yeah, if you're chem major, biochem major, you'll do that in like upper lab, like Chem 424, 425 lab. Okay, so TLC, enough about that. Okay, so in your TLC, so I drew one like there. Okay, so you do have a mobile phase and you do have a stationary phase. Wonder if this will, I don't know.